Hello, I'm Trevor Craig, and this is my mechatronics project. My project was the Sentry Car. The Sentry Car is based on an Arduino system and is controlled by another Arduino communicating over serial using XBees. The screen is an LCD screen with an I2C backpack. This really helped free up some of the pins, which allowed, as you can see, the wire mess to be a little bit less. There's a keypad which allows for multiple modes on the Sentry Car and to toggle on and off features. The joysticks are two potentiometers which control the direction of the car along with the direction of the Sentry gun. There's also an accelerometer on board which allows for motion control. Now let's go over and look at the Sentry Car before starting it up. The Sentry Car uses two servos to control the wheels and one servo here to control the up and down part of the gun and another part to do the sideways like this. It's communicated right here over XBee and includes headlights, 2 green in the front, 2 red in the back. Now the idea of this isn't just to light up a room if you can't see. It's also so when you're at far distances you can tell whether or not you're orientated how you think you are. And it's ran off of 2 power blocks. 1 power block for all the logic and another power block to control the servos. So there's also a light sensor on board. The light sensor can sense the light in the room and adjust the lights to be on or off. It can also send a signal back to the Raspberry Pi for the vision aspect and control the light intensities. Now we're going to go over to the Raspberry Pi. Code was created to search for the color red, like this. I knew the color red was going to be around a lot, especially for presentations, therefore more people could come up and just do it. There could have been the light intensity sent into the Raspberry Pi, but currently, since it's not attached and I want to do a demonstration, it is not, so it is not calibrated completely. But as you can see, by running the program, you can take a shirt like this one, and it generates a thresholded image. Now the thresholded image searches through and finds the area of the most red, for example this, and targets the Sentry gun at that point. Now as you can see, there's some background clutter and noise that will be eventually taken out because of the light intensity images and other various techniques, but I wanted to show that there is some noise that comes from this method. Using HSV you can narrow down it, but right now it's just a simple way to do it. The way it works right now is you connect and you say, hey, I want to do gun camera control from this. Sends it over XBee to the Sentry Car. Sentry Car takes it in on the Arduino, sends it over serial to the Raspberry Pi. The camera starts on the Raspberry Pi, does all of the processing for all the image parts, outputs the coordinates and all the information for the servos, goes back to the Arduino then adjusts the servos. The whole process doesn't take very long. The longest part is the camera. Using a web camera would have been a better option than the Raspberry Pi camera used. So let's power up the system and show you guys what is doable with just a little bit of hard work and a lot of creativity. And here we go again to get the project started. So I turn on the project on the controller side, followed by power to the logic on the receiver side. And then, to be warned, there will be a slight vibrations. This is due to not having the mass of the actual airsoft gun on here. So here we go. Not a lot of vibrations, which is a good sign. Let's see, it's able to be driven. 0 point turns. Lasers. And headlights, and of course, gun control. And you can do accelerometer. This allows an interesting method of being able to drive and aim at the same time. Not gonna lie, it does take a little getting used to, but it's a lot of fun once you get going. Very accurate controls, simultaneous response, as you can see. Press forward on here, it is, and instantly starts moving, so you don't have to wait. You don't even really tell that there's any delay at all. Okay, well, let me briefly explain how I was able to capture the data so quickly. Using a system of artificial delays, where the Arduino only checks so many times through the cycle of the loop, you're able to avoid data overload. And by using delays that are slightly under the human reaction time, you're able to fool the human system into thinking that it works at the same rate at which we're seeing it. So it actually is moving slightly slower than we can see, but that doesn't matter because the human reaction time is pretty slow. So that was my project for mechatronics. I really hope you enjoyed it. It was a ton of fun for me and I learned a lot, and there's quite a lot of work that involved. All of the information will be in the documents, there'll be documentation on the SolidWorks files, so all should be fine. Thanks for watching.